Are you struggling to solve this? Don't worry, let us help you out. The rational root theorem is a method used in algebra to find possible rational solutions of a polynomial equation with integer coefficients. It is stated that if a polynomial has a rational root, then p must be a factor of the constant term, and q must be a factor of the leading coefficient. By listing all possible combinations and testing them, we can quickly determine which one are actual roots, making it easier to factor and solve polynomials. Basically, we can use either substitution and synthetic division to determine which one are the actual roots. To identify the real roots easily, we'll be doing it step by step. The first step is to identify the constant term and leading coefficient. The next step is to list all possible rational roots. And the last step is to identify and test the possible roots.
Hey everyone, and my name is Angeli Marie A. Generalo. Our topic for today is rational root theorem. Our problem is 2x raised to 4 minus 3x cubed minus 4x squared plus 3x plus 2 equals 0. Our p is 2 from the last term in our problem, and the factor of 2 plus minus 1 and plus minus 2. Our q is 2 from the first term in our problem, and the factor of 2 plus minus 1 and plus minus 2.
Hello, TG here. The next step you're gonna do is to list all possible rational roots, which is p over q equals positive and negative 1, and positive and negative 2.
Hello everyone, my name is Kazumi Ikono and I'm gonna test the possible roots. First is to write the root of the divisor, which is negative 1, and the coefficient of the dividend, which is positive 2, negative 3, negative 4, positive 3, and positive 2. After that, bring down the first coefficient of the dividend below the line. Then you're gonna multiply it to the divisor, which is negative 1. Negative 3 plus negative 2 is equals to negative 5. Negative 5 times negative 1 is equals to positive 5. Then you're gonna subtract the negative 4 and positive 5. Positive 1 times negative 1 is equals to negative 1. Positive 3 minus negative 1 is equals to positive 2. Then you're gonna multiply the positive 2 to the negative 1 again, and positive 2 minus negative 2 is equals to 0. So x plus 1 is a factor.
Hello everyone, my name is Rodrigo Barbosa. So here we have a divisor positive 1. From negative 1 to positive 1 transposing. So we have 2, negative 5, and 1, and positive 2. So bring down 2. 2 times 1 equals 2. 2, then 2 minus 5 equals negative 3. Then negative 3 times 1 equals negative 3. Negative 3 and positive 1 equals negative 2. Then negative 2 times 2 equals negative 2. So negative 2 plus positive 2 equals 0. So x minus 1 is a factor.
Good day everyone, I'm Nikki Balbes Pinosa. The first thing you'll do is to write our divisor here and write the previous instructor's answer here. Next step is to bring down 2 2 times negative 2 is negative 4. Negative 3 plus negative 4 is negative 7. Negative 7 times negative 2 is positive 14, and negative 2 plus 14 is 12. Since the remainder is not 0, we can conclude that negative 2 or x plus 2 is not a factor.
Let's write our divisor, which is positive 2, and then our polynomial positive 2, negative 3, and negative 2. Bring down 2, and then multiply the positive 2 and 2, which is 4. So, add negative 3 and 4, which is 1. Then multiply again, and then add, which is 0. So, x minus 2 is a factor.
Good day everyone, I am Harley Raven in Fanta and I will teach you how to get the last divisor. So, 2 over 2x plus 1 over 2 equal 2x plus 1 equal to 0.
So our answer is x positive 1, x negative 1, x negative 2, and 2x positive 1. Before we end our instructional video, let's have a short quiz. Question 1. In the fraction, b represents a. Factors of the leading coefficient, the constant term, the degree of the polynomial, or both coefficients. The correct answer is factors of the constant term, which is the last number. Question 2. In the fraction, q represents a. Factors of the constant term, middle term, leading coefficient, or factor of the roots. The correct answer is C. Factors of the leading coefficient, which is the first number. Question 3. Which method can be used to test the possible rational roots? A. Substitution only, B. Synthetic division only, C. Long division only, or D. Substitution or synthetic division. The correct answer is D. Substitution or synthetic division. And that concludes our lesson on the rational root theorem. We hope this helps you solve polynomials with confidence. Thank you for watching.